Hi, question number 3 taken from October 2002 Advanced Level Maths HSC S2. From previous year's observations, the lengths of a salmon in a river were found to be normally distributed with mean 65 centimeters. A researcher suspects that pollution in water is restricting growth. To test this theory, she measures the length x centimeters of a random sample of n salmon and calculates that the mean of x is equal to 64.3 and the standard deviation is equal to 4.9, where s to the power of 2 is the unbiased estimate of the population variance. She then carries out an appropriate hypothesis test. Her test statistic z has a value of minus 1.807, correct to 3 decimal places. Calculate the value of n. And for the second part, using this test statistic, carry out the hypothesis test at 5% level of significance and state what her conclusion should be. Okay, so what information do we have? Alright, so this is question number 3. The information is that we have the mean, that is our null hypothesis with a mean of 65 centimeters, and it is suspected that there is a growth decrease, therefore the mean is going to be less than 65. The test was carried out and the mean was found to be 64.3. Okay, and also we have the sample size, which is unknown, and that is what we are supposed to do, supposed to find out. And there is the standard deviation, which is 4.9. Okay, and what else? Okay, so that's it. Now the z value of the test was found to be minus 1.807. So we need to find the sample size n. So the test statistic, normally the z value, is going to be the observed value of the mean minus the population mean, all divided by the standard deviation over the square root of n. In this particular case, we have z as being minus 1.807 is equal to the mean, the observed value is 64.3 minus 65, the normal value of the population mean, okay, divided by the standard deviation 4.9, and all over the square root of the sample size. So let's do out the calculation now. This goes on the other side, becomes multiplication, so we have 4.9 over the root of n is equal to 64.3 minus 65 is minus 0.7. This go on the other side, becomes divide by this. Therefore we got square root of n over 4.9 is equal to, the minus goes out, so we have 0.7 divided by, well, we've inversed this, so the 0.8, no, pretty messed up here. Okay, let us cross this out nicely. We got then 4.9 over the square root of n, alright, is equal to, the minuses go out, we have 0.7 over 1.807. So we take this further, the root of n is equal to 1.807. This goes up, this one comes down over 0.7. This one goes down and goes on the other side, becomes multiplication. And now what we have to do is just do it on a calculator. So 1.807 divided by 0.7 times 4.9. So this is 12.6 something. Right. Therefore n is equal to 12.649. All of that to the square. So square it. It's going to give us 159.997. So 159.997, so on. Therefore n is equal to 160. So that's the value of n. Now, for the second part, we need to use the test statistic to carry out a hypothesis test at 5%. So, at 5%, what do we have? This is the normal distribution curve. It is suspected to be less, therefore at 5% we're looking here, this is 5%, and this is our Z value. So what is that? We're going to calculate the probability here, so P of, let us say A being less than minus Z, that's exactly the same as 1 minus P of Z being less than A. In other words, we're saying 1 minus xi of Z is equal to 5%. Alright, so the xi of Z is equal to 1 minus 5%, and xi of Z is going to give you, so 1 minus 5, okay, so 1 minus 5 over 100, 0.95, and so Z is going to be the inverse xi of 0.95. You check this out from your table of values, you're going to get 1.645. Because we are looking at the less value here, negative value, so Z is equal to negative 1.645. The test statistic has a Z value of minus 1.807. So this means that if this is minus 1.645, the minus 1.8 falls within that region here. And this is our critical region, meaning that in this region HO is rejected. So for this particular test, we're going to reject this and we're going to accept H1. So the conclusion is that there is decrease. So there is evidence to suggest that there has been significant growth, decrease in fish in the river due to water pollution. So here we are for this question, quite nice. I hope this has been of some help to you guys.